Okay, let's look at how we make an amide from an acid chloride. Again, whenever we talk about acid derivatives like acids, chlorides, and amides, they most often come from carboxylic acid. Treat it with thionyl chloride, we make the acid chloride. And now we're going to make an amide. And I'm going to show an amide that has one hydrogen on the nitrogen. We'll see that it's very easy to put multiple hydrogens on the nitrogen, or multiple R groups on the nitrogen. And how we do this is we will end up treating this with an amine. And normally you have a base, and actually the bases couldn't be more simple. Typically it's sodium hydroxide. And of course, anytime we use sodium hydroxide, we typically have water in the reaction as well. Okay, so what's this look like? Let's show the mechanism. Start with our acid chloride, and we are treating with this amine. And of course we have sodium hydroxide in there. We'll bring that in later as we need it. So what happens is our nitrogen attacks. This is a nucleophile. The carbonyl is an electrophile. We attack, and we are going to get a tetrahedral intermediate. Now this is kind of a pain because this nitrogen still has both of its hydrogens. So don't forget it has its hydrogens. It also started as neutral. Now it's made a new bond, so it's going to have a positive charge. We do, however, get a tetrahedral intermediate. Once we talk about acid derivatives, we tend to eject groups off of the central tetrahedral intermediate carbon. We're going to do that here. So this O- kicks back down and is able to boot out that chlorine. And we get this kind of odd positively charged species. This kind of compound is really unstable. And when I say it's unstable, I mean it's a great acid. So it just so happens that we have sodium hydroxide in here. And what's that sodium hydroxide going to do? It's going to remove one of our protons. And that gets us to our amide product. So we have the amine in here. Of course, the amine's role is vital because we need to make an amide and we need that nitrogen. But we have some base in there as well because the base helps to essentially get rid of the HCl that we're going to form. Notice that we're losing a proton and we lost a chloride. And so ultimately we form HCl, so we need some base in here to neutralize that HCl. But that's a formation of an amide. If you go back and compare this to how we formed an ester, it's really the exact same reaction. Strong nucleophile attacks a carbonyl, you get a tetrahedral intermediate, then you kick out the chloride and you get your new acid derivative.